Welcome to my channel, viewers. Here we will discuss two important theorems. These are known as midpoint formula. Now this theorem one is the line segment joining the midpoints of any two sides of a triangle is parallel to the third side and half of the third side. Now this line segment EF, it is joining the midpoints of AB and AC. That means AB equal to AE equal to EB, AF equal to FC. Right? Now we have to prove that this is EF parallel to BC and EF equal to half of BC. Right? E and F are midpoints of AB and AC, and we have to prove that EF is parallel to BC and EF is half of BC in measurement. If EF is 5 centimeter, BC will be 10 centimeter. Right? Now let us extend EF and let us draw a line parallel to AB through C. Right? Now let us consider this point is say D. So we are making additional construction from C. CD is parallel to AB. Right? We are constructing CD parallel to AB, and EF is extended to meet at D. Now let us consider these two triangles here. If you consider these two triangles, you see these two angles are equal, right? These two angles are equal and these two sides are equal by given condition F is the midpoint of AC. Now you see this line CD is parallel to AB. CD is parallel to AB. So these two angles are equal, alternate angles. When two parallel lines are intersected by a transversal, alternate angles are equal. Now BA is parallel to CD. So AC is a transversal here. So this angle equal to this angle. That means this angle equal to this angle. So these two triangles are congruent, right? So if you consider triangles in triangles AEF and triangle CFD, so you find that AF equal to FC, right? Since F is the midpoint of AC, then angle AFE equal to angle CFD. They are vertically opposite angles. These two angles are vertically opposite. Then angle EAF equal to angle FCD. They are alternate angles. Right? So these two triangles are congruent. Therefore, triangle AFE equal to angle congruent to triangle CFD. So these two triangles are congruent. Now in congruent angles, you find that corresponding parts are equal. Therefore, FE equal to FD. CPCT, right? FE equal to FD. Then you find that these two angles are equal, right? These two angles are already equal, vertically opposite. They are AB parallel to CD, right? So these two FE equal to FD, right? Now you find that ED, since ED equal to BC, since it is a parallelogram, right? CD equal to EB, why? AE equal to CD. AE equal to CD. CPCT. Corresponding parts of congruent angles are equal. So AE equal to CD. AE equal to CD means ED equal EB. Uh, this means EB equal to CD. Since E is the midpoint, so AE equal to CD means EB equal to CD. Then again you find that these two are parallel. EB parallel to CD by construction. So therefore EB CD, it is a parallelogram. It's a parallelogram. In parallelogram, you find opposite sides are equal. So ED equal to BC. Now what is ED? ED means EF equal plus FD equal to BC. BC, right? So EF equal to FD. That means you can write twice of EF. Twice of EF equal to BC. Therefore, EF equal to half of BC, right? So we prove that the line segment joining the midpoints of any two sides of a triangle is parallel to the third side and half of the third side. We prove that EF equal to half of BC. And since EBCD is a parallelogram, ED parallel to BC, EB parallel to BC, EB parallel to ED parallel to BC means EF parallel to BC, right? This is parallel, not equal. ED parallel to BC means EF parallel to BC. So we conclude that the line segment joining any two midpoints of any two sides of a triangle is parallel to the third side and half of the third side in measurement. So we prove that EF is parallel to BC, whereas EF is also half of BC. So if BC is 10 centimeter, EF is 5 centimeter, right? Now let us consider the converse of this theorem. The theorem we discussed earlier. The line drawn through the midpoint of one side of a triangle parallel to the another side bisect the third side. Now here AE equal to EB. That means E is the midpoint of AB. And furthermore, EF is parallel to BC. Now we have to prove AF equal to FC. That means F is the midpoint of AC. You are given AE equal to EB and EF is parallel to BC. Now let us draw a line parallel to AB from C. That means this is suppose D, and let us extend EF to meet at D, right? So this is additional construction we are making here. Now you see we are given that EF is parallel to BC. So EF parallel to BC, that means that is ED parallel to BC, right? Since if EF is parallel to BC, ED is also parallel to BC. Then again EB parallel to CD by construction, since we are constructing this line CD parallel to AB. That means EB parallel to CD. Therefore, EBCD is a parallelogram, right? So it's a parallelogram. Now in parallelogram, you find that opposite sides are equal. So you find that EB equal to CD. EB equal to CD means AE equal to CD. Right. Now let us consider these two triangles. These two angles are equal. Right. That means again we find that these two sides are equal. Then we find that these two angles are equal and these two angles are equal, vertically opposite. So by AAS criteria, you can prove that these two triangles are congruent. Now let us come to triangles A, E, F, and C, F, D. So you find that AE equal to CD. Since EB equal to CD. EB equal to CD means AE equal to CD. Since E is the midpoint of AB, AE equal to EB. So EB equal to CD means AE equal to CD, right? Then angle AFE equal to angle CFD. They are vertically opposite. Vertically opposite angles are equal. Then angle EAF equal to angle FCD, alternate angle. Alternate angle. Therefore, what we find? Triangle AFE equal congruent to triangle CFD by AAS criteria. Right? By AAS criteria, these two triangles are congruent. Now, in congruent angles, corresponding parts are equal. Therefore, we can write AF equal to FC, CPCT. In congruent angles, corresponding parts are equal. So, AF equal to FC. That is, F is the midpoint of AC. Or we can say AF equal to FC equal to half of AC. So what we proved here, the line segment joining the line segment drawn through midpoint of one side of a triangle parallel to another side bisect the third side. We are drawing EF parallel to BC and E is the midpoint of AB. So this line EF will bisect AC. That means AF equal to FC. So to prove this, we draw a line parallel to AB from C, which intersects extended EF at D. Now EBCD is a parallelogram. Since this line is parallel to this line, again by given condition EF parallel to BC means ED parallel to BC. So EBCD is a parallelogram. Now in parallelogram, opposite sides are equal. So EB equal to CD. That means AE equal to CD. Now if we come to these two triangles, so we find that AE equal to CD. That means then again these two triangles are equal. Again these two angles are equal, alternate angles. So by AAS congruence criteria, these two triangles are equal. Congruence. Now in congruence triangle, corresponding parts are equal. So AF equal to FC. That means F is the midpoint of AC. F is the midpoint of AC. So thank you viewers for watching this video. In next video, we will try to prove some exercise based on these two theorems.